So we are talking about normal curves today. We're talking about the different ways you can represent these in statistical pictures. So go ahead and stop me at any point if you have any questions. I'm more than happy to answer any questions you have. At the end, we will go ahead and do some review problems, and then I'll obviously open it up to any extra questions that you guys have then. All right, so let's start with talking about what z-scores are. So z-scores are basically the way that we standardize any type of value that we get. So it's showing like where the observed value that we got is in relation to the rest of the values. So that's what, and we call it a z-score. So it's a measure of relative standing within on that normal curve there. And we talk about it as like plus or minus. So it's like how many standard deviations above or below the mean is. That's where that standard deviation comes into play there. And we always look at it on a z-score curve. Always has, if I can annotate here, it always has a mean of 0 and then a standard deviation of 1. So then, and all the different numbers falling on here are going to be our z-scores down here on the x-axis there. Alrighty, so another thing that we talked about is the empirical rule. So basically our empirical rule is just talking about how our data is distributed, how much of it is within certain different like aspects of the normal curve. So once again, this is the same idea that we have a mean of 0 and a standard deviation of 1. So we have our, so here's our mean of 0, standard deviation of 1. As we can see, we go over plus 1 and then minus 1 on each side here. And then the way that we read this is that 68% of our data is within plus or minus 1 standard deviation of the mean, okay? So if we go out 1 standard deviation, we end up here, and we go to the left 1 standard deviation, end up here. And this is saying that between these two lines underneath the normal curve, we have 68% of our data. So where I'm shading here right now is going to be 68% of our data, okay? And then if we were to clear this, just to represent then, if I talk about plus or minus 2 standard deviations of the mean, that's where 95% of our data is going to lie. So that's all this area in here, between plus or minus 2 standard deviations. And then the same thing goes for 3, but I won't be redundant with that. So, all right, cool. So, and then to keep in mind when we're showing our data on statistical pictures, we want to make sure we have a clear picture that we're showing. So this picture has to be clear. We have to make sure that it's definitely, it stands out from the background, doesn't blend in, and we want to make sure we label it correctly, because if we don't label it well, then obviously, you know, we could have really good data, but then if it's not displayed correctly, it's not really doing us any good. So you always want to make sure you have a title, so you, you know, the people looking at it know what we're talking about. The purpose of the data should be stated, because we can just have our data, but we want to say like why we collected this, and then also make sure that you label the axes and include the scales on them. Make sure we know what the axes are being measured in. And the whole keep extraneous material to a minimum, that's just saying the same idea, that you want to make sure that you don't have a bunch of extra stuff that you don't need. Don't want any distractions there. All right, so that's just a quick review. This is a pretty quick lesson this week, so we'll go ahead and do some review questions. So, go ahead, I'll read through these, and go ahead and type your answer into the chat box, and then we will go through them together and go over them. So this first one says the heights of women are normally distributed with a mean of 65 inches and a standard deviation of 3 inches. About 68% of the heights for women fall between what? So go ahead and look through these answers and let me know what you think, and then we will review them together. All right, so great job. Yeah, so our answer is definitely C here. So remember, 68% of our data always lies within plus or minus 1 standard deviation of our mean. So if we draw out on our curve again, in this case, if we were to look at this, it tells us that our mean is 65 inches, and then our standard deviation is 3. So if we were to go up and down 1 standard deviation of this mean, we're going to end up getting 62, because that's minus 3, and then 1 standard deviation up would be plus 3, and then this would be 68. So then our answer would be C, because 60% of the data is going to lie within this realm here. It's a great job. Our answer is C there. All right, let's try another one. So what do you need to check for first before using the empirical rule to describe a population? So read through these answers and let me know what you think, and we will review it then. Okay, great. No, that's totally understandable. So A is definitely, so you're not necessarily wrong by saying that, because we do always want to have a large sample size, but this says you want to check whether or not the population is large. So if you remember, when we talk about populations and samples, our populations are the fixed like groups that we have, and then the samples are the ones that are variable because we take them from the population. So our population doesn't necessarily have to be large. It doesn't really matter. But what does matter when we're talking about the empirical rule is that we have to have our population be normally distributed, because if it's not, then we can't apply that idea of being plus or minus 1 standard deviation, plus or minus 2, etc., because those are they only come into play when we have a normal curve. So C, this is just saying you need to check whether or not 60% of the population did it. Like this is true if we have a normal curve. So like C would be true if B was true first, but basically out of all these, B has to be true first before the rest of them. And like I said, the population size doesn't necessarily matter. So yeah, just the main thing is that you can only use the empirical rule when we're talking about a normal curve, because if we had a population that was like skewed and wasn't normally distributed, I would not be able to go in here and like do plus or minus 1 standard deviation and like say this is 68%. Like that doesn't work because this is skewed. So we can't use it on skewed distributions. It does have to be normally distributed, because if you remember on the actual picture that the actual picture of the empirical rule, this looks like a normal curve because it is. So just keep that in mind. It has to look similar to this in order for us to use these different characteristics of it to define it. Okay, great. Awesome. Alrighty. All right, number 3 is measured by the Stanford Binet test. IQ scores are approximately normally distributed with a mean of 100 and a standard deviation of 16. So draw a picture of this one if this helps you on this one. So because of the empirical rule, we can conclude that approximately 99.7% of all IQ scores will fall between what values here? All right, great job. Yep, so our answer is definitely E here. So if we remember, when we're talking about, like if we apply the empirical rule, 3 is going to be our multiplier here, because 99.7% of the data lies within plus or minus 3 standard deviations of our mean. This is 99.7%. So we have our mean, which is going to be our point estimate always. So our mean's 100 plus or minus, and then our multiplier, which is 3 because of this 99.7, times our standard deviation, which is 16. So that's where we get E from. So good job. Alrighty. All right, which of the following describes measurements that have a normal distribution? All right, great job. So that is absolutely correct. So C is our answer here. So if we go through the rest of them, A is not correct because remember, normal distribution, this 68% is significant when we're talking about the percent of the data within plus or minus 1 standard deviation. It doesn't have to do with being above an average or anything, so that's not the correct answer. B says the farther away you move from the average, the more individual will have to measure those more extreme values for their measurements. That's not true. It doesn't have to do with how far away you're moving from the mean. And then, so obviously D is not true because C is the correct answer because our mean is always the center of our bell-shaped curve. So, you'll draw these many times, but just as a reminder, this is going to be our mean, which is also the center. All right, great job. I think we have one more. All right, suppose your score on the GRE was in the 90th percentile. That would be awesome. Mine is not. Okay, so what would this mean in this case? Go ahead and choose through those 4 answers. All right, absolutely. You're definitely correct. So percentiles talk about the percent of scores that are at or below the one that you got. So if we're talking about your GRE score being in the 90th percentile, that means that you are at or that 90% of the scores are at or below your score. So if we were to look on, like if it was on a curve like this, if this was the 90th percentile, this is where your score is. This is going to be 90% of the data. So this is going to be 10%. Because remember, all under, this all has to be 100%. So your 90th percentile means that 90% of your data lies at or below your score. So that means that C is correct because 10% must have scored higher than you did. So that's that. All right, good job. All right, so that's all the review we have for today. So you can obviously watch this video back and the other ones from last couple weeks' lessons on the YouTube channel. And there's a link to that also on your review sessions page. Our next review will be next Thursday, the 28th at 8:30 for our next chapter. If you have any, go ahead, ask me any questions you have at this point. We can go over anything from this chapter, so just let me know. Okay, yeah, so this is definitely something I always remembered this was something that would trip me up too. So let me see. You're welcome. You're very welcome. So positive and negative association, the best way to look at that is to see what the association is going from left to right. So if I drew, let me see if I can, there's a way that I can share like a whiteboard. All right, here we go. Okay, so if I were to draw, I'm going to draw different associations here, and we'll discuss why they're positive or negative. So if I drew this one here, and the dots are looking something like this. In this case, what you want to do is go from left to right, and then decide what direction it's going in. So in this case, if we start at the left and move to the right, we're going in an up direction, so this is going to be a positive association. But then if I were to draw another curve over here, and our dots were going like this, once again, if we go from our left to our right, so we start up here in our left and to our right, this is going downwards. So then this is going to be a negative association. Does that make sense? All right, great. Any more questions for me? Okay. Okay. All right, you're fine. You're totally fine. Well, let me know if you have any other questions. If not, you are good to go for the week then.